All right, so we're going to get started because I want to be able to go over our answers that we might have come up with on our practice on Wednesday. And then I'm going to go through the steps on how to solve for angle measures within triangles. And then we're going to start all over and do it again on Monday so that we're all on the same page. So I wanted to make sure that you had a video to watch and reference just in case some of you wanted to get a head start with some of the things that I've posted. So with that being said, let's take a look at number one. Again, we're going to find our side lengths and we are going to look at our angle. And again, when we look at a 53-degree angle measure, a couple things we want to keep in mind. It has to be trig. That we're going to use because it's not a special right situation. We don't have a 30-degree angle, a 60-degree angle, or a 45-degree angle that would make this one of our special rights. So we have to use trig because we are looking for the other two sides. We also know it can't be the Pythagorean theorem because only one side is given. So we need to make sure that we're recognizing what we're picking, not just how to do it. So again, we need to recognize what are we actually looking for and then how do we use it. So it has to be trig because it's not going to be a 30, a 60, or a 45-degree angle to put it in one of those special right situations. And we know we can't use the Pythagorean theorem because only one side is given. If two sides would have been given, then we could have chosen that. So now that I know that it has to be trig, we are going to start by labeling, according from our reference angle, what our opposite side is, what our adjacent side is, and then always our hypotenuse is across from the 90-degree angle. Because our first side that we're going to want to look for is AB. I look to see that AB says adjacent, and the only other known value that's going to help us with our equation is the hypotenuse. So we have to decide which of the three trig ratios am I going to be able to use. Now, whether you write it on your own paper or scrap paper, don't forget this guy will help you remember, if you don't have it memorized, which trig function to use. So remember, this is sine, opposite, and hypotenuse. You've got cosine, adjacent, and hypotenuse. And then this one is, anybody else bothered by the fact that I put my arrows in different directions? Yep, I totally am. Tangent, opposite, and adjacent. So I can use this as my cheat sheet. I'm going to put it off to the side. And again, adjacent and hypotenuse. In each one of these separate categories, I want to figure out where adjacent and hypotenuse happen at the same time, and that's here at cosine. So I want to use cosine to solve this because I can fill in enough of the equation with the unknowns to solve. So I'm going to write cosine, and instead of A or instead of theta, we have the 53 degrees to plug in. And its ratio is supposed to be adjacent, so that's our side AB, over the hypotenuse, which is 12. So we've plugged in all the unknowns to our definition, our equation, And now we have to go to our calculator and, as I have a glare, sorry, we have to plug in. We have to first make sure this guy down here says DEG, which it does, and if it doesn't, you push this button until you see that DEG, you can arrow back and forth, is underlined. Push enter, and it will make sure that says DEG. We need it to be in degree. So then we simply push the button for cosine. It's telling us to use cosine. 53, enter. And remember, this is a ratio. It's just in decimal form. So we're going to write that ratio, but in decimal form. And we're going to carry it out a few places, but it's just to keep track. It is absolutely not going to only be those. It's going to be all of these, and I'm going to keep that right there on my calculator. I'm not going to push clear. I am going to write it over 1, again, just to stress that I know this is a ratio, even though it's in decimal form. And it's also going to help when I go to solve, because then it sets up in a proportion. And in order to solve a proportion, we cross multiply. So in this case, we're going to cross multiply 1 times AB. We're going to cross multiply 12 times our decimal. Well, 1 times AB is just going to be AB. And now that I have my decimal, I'm going to multiply that by 12. And what I end up with is this number. Now, I did talk yesterday, or excuse me, Wednesday, about round to the nearest tenth. A lot of worksheets say round to the nearest tenth. On the other hand, I did a lot of the no-re questions from 9.5 and 9.6. They want everything rounded to the nearest hundredth, so that's 2 decimal places. So I have my first decimal place, the tenth is 2, the hundredth is 2, and I look to the thousandths, and that one will tell me whether I round up or stay the same. And I'm going to stay the same because this guy is between 0 and 4. So we have approximately 7.22. And if this was one of your no-re questions, you would plug it in like that. I also want to figure out what BC is. So what the length of BC is. So this time I want to take a look. And BC is now opposite. So if I'm looking at opposite and hypotenuse again, those are my 2 knowns. I look for opposite and hypotenuse up here. And where opposite and hypotenuse fall in the same category, it's with sine. So that's why I'm choosing sine, because I can fill in everything according to this equation. So now we're going to do sine and our degree, and then its ratio, opposite over hypotenuse. And now the steps are the same. We're going to go ahead and we're going to go to our calculator to figure out what that actual ratio is. And it's in decimal form again. So we have sine 53, enter. And that's going to give us 0.7986. Again, those decimal places are just randomly thrown down there because I'm not going to just use these. I'm going to use all of these. So again, and I see, Beth, you just wrote something down. Let me finish this and I'll answer your question. Again, sine 53, we're going to use all of these, but I only wrote down a few. And now we have our proportion. So before I cross multiply, before I solve, let's go ahead and let me take a look. And it says, I'm having trouble how exactly you figure out which ratio to use. Okay, find the certain things because the difference depends on what you're, yeah, and that is true. So what you have to pay attention to is what are you choosing to solve for? So in the first one, when we chose to solve for AB, I looked to see what side AB was on. And I looked to see what the only other number was that they gave me. And because this side was adjacent and this side was hypotenuse, when I look at either my formula sheet or I look at this guy, which is our cheat sheet, the mnemonic device, SOHCAHTOA, we have to remember that our sine equation or our sine definition is sine of some angle equals, so now we have an equation, the opposite side length of whatever the angle is we're talking about over the hypotenuse length. So it's actually this equation, and because I have the degree, 53, and I have the hypotenuse, the only unknown would go in this spot. So then I have enough information to solve an equation. If I wanted to talk about cosine, it would be pretty much the same, except it would be the adjacent side length of angle theta divided by the hypotenuse. And tangent would be the tangent of theta equals the opposite side length of theta divided by the adjacent side length of theta. And in our formula sheets, it looks like this. And that's probably the easiest way to remember that these are equations. And anytime we want to solve for a missing piece, we should have enough to plug in everywhere else. So when I chose, so again, I'm moving it just above my paper, so I have my formulas. When I knew I wanted to solve for AB, I saw it was adjacent. I saw I had my angle measure. I had the hypotenuse, so I was able to plug in for every unknown except one. And then we can use that information to solve for that one unknown. This is found in my calculator. I recopy, and then because it's a proportion, we can cross multiply and solve. When we changed sides, so when we chose to then find BC, BC was on the opposite side of our reference angle. The hypotenuse is still the only actual value that's given. So because opposite and hypotenuse and an angle, I look to see which I can plug into so I only have one unknown. Well, I have the angle, I have the hypotenuse, the only unknown is opposite. So that's why we chose this to solve for that side. So sine 53 equals BC over 12, opposite over hypotenuse. We went to our calculator to find what that actual ratio is in decimal form, and then we set it equal to that fraction, creating this proportion. Yes, you just look at the sides that you're using that are given, and that will tell you. So it's not like I said, I think I said it a couple times on Wednesday, I'm not just choosing one because it seems to be my favorite. It all depends on what I'm looking for and what's given. What I'm looking for and what's given. And that'll tell me which of the three that I'm using. And once I plug that, push that button for the ratio, the rest turns into our pre-algebra concept of cross multiply and solve. So 1 times BC is just going to be BC. And because we are going to round, I'm making that finally on the first try, because if you look, all of my equal signs I had to change. Now I have my sine 53 is still here, and I'm simply going to go times 12, and it's 9.583. Well, the 3 tells me to keep the 8. So this would be 9.58. And we're done. So yes, it is all about which side I'm looking for. So let's just start again with number 2. And I know you had a chance to look at this one, but I'm going to ask you if I'm looking for x, what trig function, and it's very possible, Beth, it's just you and me, so I feel bad. I wish we would have just Zoomed and then we could have talked. But if you would, type in, if we're trying to find x, what trig function you think we're going to need. If it's sine, cosine, or tangent, and I am going to tell you that as you think about it, I'm going to go through the steps of circling my reference angle, labeling my hypotenuse, my adjacent side, and my opposite side. And again, if I'm trying to find x, I want to look that x is adjacent, and the only number they give me is opposite. So out of all three of these, which one has opposite and adjacent? So I'm going to give a second for a good guess. All right, so I will agree opposite is a part of sine, but we also are looking for x, which is adjacent. So I need opposite and adjacent to appear in the equation. Opposite and adjacent to appear in the same equation. Yep, tangent. Now don't forget, sine's going to actually come into play, ironically, but tangent is the one we want to use for x. So we are going to do tangent 30 equals opposite 8 over adjacent x. So again, that's because we're doing opposite and adjacent. Correct. If I wanted to use sine, it would have to be opposite and hypotenuse, because that's the definition for sine, opposite and hypotenuse. So you will see that it's going to come into play, and it's actually going to solve for y. But if you gave that as your answer for x, it's wrong. So when we go to find y, it's going to be sine, because opposite and hypotenuse will help solve for y. All right. Now that I got the right equation, I go to my calculator. So tangent 30 is that number, the 0.577. So we're going to do 0.577 over 1 equals 8 over x. I am not going to erase my calculator at all. Don't push clear. I am going to cross multiply again, and this time I have that crazy decimal times x, and I have 1 times 8. So what that means is I have to divide to solve for x. So I'm going to need every one of those decimal places in order for me to solve. So without clearing my calculator, I'm going to push 8 divided by, and instead of typing all those back in, remember I can do second answer, and it'll cut and paste everything in for me, and now I have that value. And because I'm rounding to the nearest hundredth now, notice that it's 8 is in the tenths, 5 is in the hundredths. This guy tells me I have to round 5 up. So when I write my answer for x, it's going to be 13.86. And I'm doing that again because when we plug things into no-re, they are asking for the hundredths place. And if the rounding is wrong, because I tinkered with that a little bit, your answer will be wrong. You could do all of this right, and you could have written down 13.85, and it will be wrong in no-re, and you will think that you got this part wrong. Instead, we just got something simple like rounding incorrect. So be careful with that. Now we're going to go back because we did already mention that if we're trying to find y, the value that they give us is opposite. The one we're trying to find is hypotenuse. So again, when we look at opposite, where opposite and hypotenuse appear at the same time in one of these equations, it's sine. So when I'm trying to solve for y, I have to choose sine because that's the sides that match. So now we're going to do sine 30 equals opposite over hypotenuse, 8 over y. So I'm going to go to my calculator and I'm going to go sine 30, enter, and that is a really nice fraction. I am going to annoyingly stick to our pattern of our decimal over 1, even though I could really write this as 1/2, equals 8 over y. We are going to cross multiply, and we do get 0.5y equals 8. When we divide both sides by that 0.5, you end up with y equals 16. And it is equals because it is an exact value. I am going to point out, I purposely wrote this here because it has to be trig here because it doesn't fit our Pythagorean theorem or one of our special rights. Over here, we had a choice. We could have solved for x and y using trig. Some people find that faster and easier. Others would have said, wait a minute, that's a special right situation, and better yet, it's opposite the 30. So this is a. This is a radical 3, and this is 2a, and most people right away would say 8 radical 3, 16, done. And notice 8 radical 3 is the answer we got here. So it just depends what you could choose to do, not necessarily you have to. Just remember, if they ask you to round, you need to do decimals. So we could have solved by using our special right 30, 60, 90 formula. Again, some find one way easier, some find the other. All right, so the last of our practice problems, I actually took this off of a no-read question. That way it was similar, and it described it for us. If 28 degrees was the measure of angle D, and DE was 42 centimeters, we want to find the other two sides. So we are going to start with our reference angle. We're going to label our hypotenuse, our adjacent, and our opposite side. This time I'm going to cut back on all of the notes and just write it out. If I want to solve for EF first, that's these two, opposite and adjacent, I'm going to choose tangent of our angle equals opposite over adjacent. So it's the same setup, it just looked a little different. Tangent 28, enter, and we have 0.5317 over 1 EF over 42. And again, I'm just choosing random value, a random length here for the decimal because I'm not clearing it from my screen. I'm going to cross multiply and solve. 1 times EF is EF, and 42 times that decimal will be about 22.33. If I want to solve for DF, DF is our hypotenuse. Our given value is adjacent. So adjacent and hypotenuse this time is cosine. Adjacent over hypotenuse is cosine. So cosine of our 28-degree angle will be adjacent 42 over hypotenuse DF. So cosine 28, enter. Sorry, pushed the wrong button. Cosine 28, enter. And we have a decimal of 0.8829 over 1 equals 42 over DF. We need to cross multiply. So that ends up being the 0.8829. So our crazy decimal times our unknown is equal to 1 times 42, which would be 42. We need to get DF by itself, so we're going to divide away that decimal. And again, to help myself, I'm going to take 42, I'm going to divide, and then we're going to do second and that answer button so that it cut and pastes everything in. And we end up with DF is about 47.57, because again, 5 or higher rounds that up. We're done. So those were our practice questions, depending upon if you tried them. But I could understand it does feel, and everybody always asks, how do I know what I'm picking? And when we're solving for the lengths of sides, we have to make sure that we concentrate on which one we're choosing and what's given. And then those two values will help us decide which one of these equations we're plugging it into. So we're going to switch gears real quick. And again, this is more so for you, Beth, if you want to get a jump start on things, get things taken care of out of the way. For those that might be watching the video later, I want to at least give you a little taste of what's coming on Monday, and then give you the opportunity maybe to practice some questions or email me if you have any questions. So we want to use Trig now to find the angle measures. Now what's good about this is it will address that question quite nicely where you were asking, how do I know which one? So we want to find the measure of angle A and the measure of angle C given the right triangle. All right. So in our right triangle, our acute angles are the ones that we want to be looking for. Again, we cannot use trig functions to find anything that has to do with our hypotenuse or the 90-degree angle. We want to, it always deals with our acute angles. And the given information is going to be that I will make this side 12 meters and I will make this side 19 meters. I want to find the measures of the angles. So I could, if I was asked to find length of AB, I could do the Pythagorean theorem, simplify and be done. I'm not asking for that right now. I'm asking for the measures of the angles. So I'm going to approach this the way we did with our side lengths. our first step find the angle that we're solving for. Label sides, opposite, adjacent, and hypotenuse. So very much like what we did on Monday with finding side lengths, we're going to use we don't have a reference angle this time because we don't have a value for the angle measure, but we do know, figure out what angle A is. That's the first one they told us to. So again, we're going to find our angle. We're going to label opposite, adjacent, and hypotenuse, all because of that angle. Everything's in reference to this angle from that perspective. The second thing that you're going to do is choose which trig ratio and essentially the equation to use based on the given side lengths. So where before you were asking, how do I know which ones to choose? Well, what did they give you and what were they asking for? Well, now it's not what are they asking for. In both cases, they're giving us exactly what we need. And specifically here, they're giving us opposite and hypotenuse. So in this case, given 12, which is opposite, and 19, which is hypotenuse, these two work with our sine function. And so that's why we're going to choose sine. All right, so again, because we're using and we're finding angle A, we're looking at what we've labeled, and now it's telling us these are the two you want to use. These are the two values that we want. So up here, we're going to now do sine. We want angle A equals opposite over hypotenuse, so 12 over 19. So in this whole equation, we still only have one unknown. Before, when we were working the other ones out, like in this guy, we had one unknown. So the same equation, the same ratios will help us solve again. Now, in order to solve, the next step we have to do is we have to undo sine. So we want to solve for A, the angle. Okay, we want to solve for A, which means when we solve, we have to undo an operation. So I want you to think, here's my brain bubble, if I had 3x equals 12, we would want to undo this operation. And so 3 times x would equal 12. If I wanted to undo that operation, I know that I need to pick the opposite operation. And I would divide. So when we undo the operation over here, we chose division to help because they were opposite operations. So when we undo an operation to solve, we're using the opposite operation, and that's pretty much what we say. What's actually said in math books is it's the inverse operation. And that's what we're actually going to apply to our equation. So in order for us to solve for angle A, we have to use the inverse of sine. And that's actually called, looks like that on my calculator. And that's inverse sine. So it's going to undo sine like division undoes multiplication or vice versa. So inverse sine is what we're going to do. The way it looks up here, what you do to one side, I'm going to rewrite the sine A. You have to do to the other. And we're going to rewrite the 12 over 19. So a lot of times people like to just write it floating in front here and floating in front here. I think that looks kind of messy for notes. So in front of each part of the equation to undo it. So over here, notice how I had divided by 3 on both sides of the equal sign? Up here, I'm doing the opposite operation of sine to both sides of the equal sign. So of course, what happens when operations are opposite? They cancel each other out. Well, when operations are opposite, they're going to cancel each other out. And what that leaves me with is the measure of angle A is going to be equal to this crazy looking guy. And what's great about that is it's all in your calculator. So when all of these steps are done, the only real thing you ever have to do is you go right here. Above each one of these, and you can kind of see it here, we have sine, and to undo sine, we have inverse sine. If cosine is the one we had to use here, then we would undo it using inverse cosine. And if tangent was the one we were forced to pick here, we'd undo it using inverse tangent. So again, I had to pick sine because it fit the equation. To solve, I use the inverse of sine. So I come here and I push second sine. Notice how inverse sine shows up. And I'm going to use 12 divided by 19. And I do the division symbol because if I kept using the fraction bar, it might get messy with decimals. And now what we actually found was what the measure of angle A is. So the measure of angle A is about 39.17 degrees because we have to round up. So again, I wrote out all the steps, but it all starts the same way. Find the angle you're talking about, label the sides, choose which one of our equations we are forced to use because of the two given values, which was sine. The only new part now was to undo sine to solve for A. We have to do the opposite operation. Now we've got to actually find C. But that's the fun part. These are complements. They have to add up to 90. So to find the measure of angle C, we simply do 90 minus that 39.17. So 90, got dark all of a sudden, minus 39.17, and you get your answer for angle C very quickly. And again, oops, it's approximate, and it's 50.83 degrees. And I am going to make sure that without a doubt, put the degree symbol with it so that we know that we're talking about degrees and not side lengths. So let's just review before we do the last example, and then we're done. We said we wanted to find the measure of angle A and then the measure of angle C. So we circled A, we labeled the sides, just like we start every problem up to this point. Then we want to choose which trig ratio. Well, they gave us opposite, they gave us the hypotenuse, and so it fits this equation, leaving us with only one unknown again, but this time the unknown is the angle. In order to solve for the angle, we have to use the opposite operation or the inverse operation. It's called inverse sine. So inverse sine to both sides. Remember, what we do to one side, we have to do to the other to keep it equal. And everything then is done in your calculator. So I am going to put a little note by this. All final in calculator. Calculator. So everything we do is then plugged in with our calculator. So this would be second sine 12 divided by 19. Enter. So again, second sine 12 divided by 19, enter, and it gives us our angle measure. All right, one more example, and then I am done, and hopefully if we watch this, we'll see our steps a little more clearly. So example. And I'll make this real easy. It's a 3, 4, 5 right triangle. And we want to find the measures of the acute angles. All right. So we want to figure out what x and y are. Those are our acute angles. Those are our complementary angles. We know they have to add up to 90 degrees. So alphabetically, x comes first. So we're going to go ahead and choose x. That's the only reason. Opposite, adjacent, and of course our hypotenuse. So again, I'm going right through the steps. First step, figure out what angle we're using for and label. I then want to look at what's given. The two numbers that are given are adjacent and opposite. So adjacent and opposite have to fit one of these three formulas, and it has to be in the same one. So adjacent and opposite only happen in tangent. So we're going to write tangent of x equals opposite over adjacent. This time, to undo tangent, we have to do the inverse tangent to both sides. So again, I like writing it out for notes. And one of the no-read questions actually has us just doing this. Doesn't have a solving, but it says, what's the equation when we try to find the value for x? And this is what you would plug in or select. And then if it's just the equation, you're done. If it wants you to solve for the angle like I do, you go to your calculator. And this time, because we're undoing tangent, we have to make sure that we go to, wow, it is dark, second tangent, and we do our 4/3, enter. And we find out that the measure of angle X is approximately 53.13 degrees. And to simply find the other acute angle, to find the measure of angle Y, because they are complementary, we are just going to subtract that value from 90 degrees. So 90 minus 53.13 will make the measure of angle Y approximately 36.87 degrees. And I don't know what you guys are thinking while you're watching this, but I always found finding angle measures easier because it was less work. Everything was done in the calculator, and I just had to subtract to find the second one. So as we finish up, I am going to make a note that that part is done completely in your calculator. And that way we don't forget. So I am going to go through all of this again on Monday, as well as our side lengths. I did already load the homework for the chapter for this section. It is not due, obviously, I guess, finally, until the end of the quarter. However, I did put a due date for, I think, 2 Sundays from now. You'd have to read Google Classroom for that. So, Beth, so thank you. Do you have any questions before we sign off for the day? All right. Have a great weekend, and I will talk to you probably again on Monday. So thank you very much and have a great day.